Alright guys, I'm not sure what happened. The iPad turned off on me for some reason. But let's go back and let's look at this. We came up with x to the fifth minus 1, and we were trying to figure out the pattern that comes from what we have seen. What we're realizing that if we multiply a polynomial times x minus 1, then what we end up with is x to the nth plus 1 minus 1. That's our answer. Just like here, we multiplied an x to the fourth power. We ended up with an x to the fifth power minus 1. And if you go back and look at the other examples that we did, you will see that. Alright? Looking at number 3 and number 4. Number 3 wanted us to multiply. So what we did is we're multiplying that x times everything and that negative y times everything, and we end up with x to the fourth minus y to the fourth. Now what we're doing is we're multiplying x squared minus y squared times x squared plus y squared. Using the distributive property, we do that, we end up with x to the fourth minus y to the fourth. So what pattern are we seeing? What comes from this? We look at this. When we multiply x to the nth minus y to the nth times x to the nth plus y to the nth, I can let anything be y, or anything be n. 2, 3, 4, 5, whatever. And I'm going to find out that what happens is it comes out x to the 2nth minus y to the 2nth. If I'm multiplying x squared and x squared minus y squared and x squared plus y squared, look at what I end up with. I end up with x to the fourth minus y to the fourth. So basically what I'm doing is I'm multiplying my exponent times 2, and that's what my answer is going to give me.